All right, B. Find all points on the curve where the line tangent has a slope of 1/2. What did you do? You set the derivative equal to 1/2. Okay. I would bet anything that just writing that, not doing anything else, just writing that, 1 point. Because you showed that you know the slope of the tangent comes from the derivative. You showed you know calculus. Again, now is the hard part. You'll find that the easy part is the calculus, the hard part is the algebra. Now we have to show this, okay? Cross multiply or do something to clean up the algebra. I get something like that, yay?
Yes.
All right? If you do that, the two y's drop out and you get 0 equals negative x or x equal 0. Is that a point? X, y. It is not an x, it's an x. And so now you need to find the y. How do you find the y? Do you go into the derivative or to the original? The original. Y squared equals 2. So y is plus or minus root 2. Writing your answer then. The points are 0, root 2, and 0, negative root 2. The points then, there are 2 points for that. 1 point for you set the derivative equal to 1/2. 1 point for finding the coordinates x and y. Okay? Give yourself 0, 1, or 2 there. Yes, ma'am.
How do you know to go back to the original y?
Good point. So that's a good question. The whole time you're talking about, and please don't, I know some of you are visual, but you're going to be dealing with, I guarantee you, you're going to be dealing with equations that are just, you're not going to know what the graph is. And as much as I would love to give you the graph of this, it's a parabola on a rotated axis. We're just not going to go there. We can't. You're not going to know that. So the point is, though, that you're talking, when they say on the curve, that's back to the original curve, not, the derivative tells you the slope of that curve, but when they make a reference to the curve, they're saying mean. Okay? So that's the only way you're going to get points on the curve is to use the curve equation.
So how do you know that x equals 0 is on the curve?
Good point. Okay, so that's a really good question. A good question was, how do you even know x equals 0 is on the curve? Because it's entirely possible that's over here. Now, if that happens, you'll actually see an impossibility later. Maybe you'll get an imaginary number for I or something. That would tell you then that there are no points on the curve where this is happening. So that's a really good question. It's possible that that leads you into a place where, wait a second, I'm not getting any point. Well, then you conclude there are no points such that. Of course, they wouldn't say show there are points. That would be misleading. It would kind of make you think there are points. They might say show there are no points, in which case you'd show it's only imaginary. Great question. Okay, part C. Show there are, speaking of show there are no points on the curve where the line tangent to the curve is horizontal. Please don't do like I do. This is just terrible math working all over the place. You have room, I don't. Okay? C, show there are no, actually, okay, I'm going to actually use my bad work as a guide here. Math is done left to right, top to bottom, okay? And please don't start the problem over here and then say, okay, that's hard to read. Don't do that, okay? Don't do that. All right, so at that said, if I wanted to show where the tangent line is horizontal, how do you know the tangent line is horizontal? Tangent horizontal if slope is 0, which means the derivative is 0. Look at, okay, that's a little more. All right. So the slope is 0. Now let's talk about that. Do I get a 0 from a fraction if the top is 0 or if the bottom is 0. If the top is 0, the function is 0. Bottom is 0, the fraction's undefined. Okay, so if they want this to be 0, then what does that imply? That y is 0 or 2y minus x is 0? Y is 0. That's a pretty soft point. Not a super soft point, but a pretty soft point. You're saying the derivative equal to 0 and saying it must be the numerator. That, you'll see in a second, is a point. Now then, the hard part of the question again. Show there are no points on the curve. Okay, so at this point we're getting towards Haley's question. Why is there no point such that? So what should I do? If y equals 0, I need to show that that's on the curve, so I go back to the curve equation. If I put a curve equation together, then I'm putting a 0 in for y. 0 equals 2 plus x times 0. Doesn't that simplify to be 0 equals 2? Now that's not true. And therefore, that's what leads you to conclude there is no place where y equals 0. Y equals 0 isn't on this curve. That is something like the justification you would have to show by plugging 0 into the equation. You get a nonsense answer. You follow me? Are you with me? Okay. Please, this is meant to be a learning experience. So if you have questions, ask. Okay. Give yourself 0, 1, or 2 there based on what you did there. Did you set the derivative equal to 0 and conclude the top must be 0 to get that y equals 0? And did you then further explain why that y equals 0 doesn't work? D, differentiating with respect to time now. I've got this equation, but I'm not taking the derivative of y with respect to x like I did in part A. Now I'm taking the derivative of the whole thing with respect to t. So if I take the derivative of the original with respect to t, I guess I'll do that here. Sorry. The derivative of y squared with respect to t, what is it? Chain rule. Derivative of the outside is 2y times the derivative of the inside. Now I'm saying what's the derivative of y with respect to t? It is 2y dt equals derivative of 2 is still 0 plus now the product rule, but this time with respect to t. So x stays the same. Derivative of y with respect to t is 2y dt plus y stays the same. Derivative of x with respect to t is dx dt. Okay, cool. They're related by functions at blah, blah, blah. At time equal 5, the value of y is 3, dy dt is 6. Find the value of dx dt at time 5. Let's identify what we're solving for. We want this stuff. Yeah? Now, you can either solve for that algebraically, then put all the numbers in, or put all the numbers in, then solve for it. It doesn't matter. What do you want to do? Solve for it algebraically, then put the numbers in, or substitute numbers first? Solve it algebraically? Okay, sounds good. If you did it the other way, that's fine too. Is dx dt, and there's only one, so thankfully we don't have to do any of that factoring stuff. But I think you'll agree that dx dt would be the idea of 2y dy dt, subtracting that guy over, minus x dy dt over y. So isolate dx dt. Are you with me on that? All right, now let's substitute. If I substitute, do I have y? Man, I am all over the place. I would hate to read my word. Dx dt is, what is y? 3. So I have dy dt. Like this. 6. Okay. Minus x. What's x? I don't have x. What's x? How do I find x? Plug in 3. Plug in 3. 3? Yes. I can plug 3 in to where? I got equations all over the place. I got the original curve. I got its derivative. I got its new derivative, where do I put 3 in? 3 into the original curve. Okay, so if I plug 3 into the original curve, I'm asking when y is 3, what is x equal to, so I can substitute into my derivative. Well, if I plug 3 in, I get 9 equals 2 plus 3x. So what's x? 7/3. It's okay if that's ugly. Don't think you did it wrong. That's fine. No worries. Okay. So x is 7/3, and dy dt is still 6, right? 6. I'm having trouble writing outside the margin. Over y is still 3. Now, I'm not big on this part of the AP test, but if you on the AP test you left it there, you would get full credit. That makes me angry. I mean, it's math. You should get a no. That bothers me. But if you went on and cleaned it up just because you want to do good math, then it would be something like 36 minus 14 over 3, or 22/3. All right, if then you were to grade that, it is, okay, so they did their things in a very different way. They solved for x first, so this and this would be separated from me. I used the chain rule first. I took the derivative first. So 1 point is for the derivative with respect to t. 1 point is for plugging the values in. And 1 point is for solving for x. So depending on the order in which you did things, you might have had those in different. But those are the big ideas. Did you take the derivative properly? Did you sub in all values properly? And did you solve for x properly? Or, oh, actually, take it back. I misread that. When I say solves for x, that is that. Did you find that 7/3 point? Sorry. If you found x is 7/3 when y is 3, you get a point. You get 1 point for the derivative, and then 1 point for the answer. Give yourself 0, 1, or 2, or 3 there, and give yourself a big old total at the top of the paper. If, I got news for you. If you got a 0, that's okay, because today's not the AP test. Just learn from your mistakes. I took this here. So could you say it again? So you got a point for the derivative. You did not find x, so you would not be able to. I get you. You get the chain rule correct. So you get that. Yeah, because you did some x, you couldn't get it correct. All right. Can you pass those to the, I don't want to embarrass, whatever, can you pass it to the middle, please? If you're embarrassed, then walk it up to me, whatever. I gotta tell you right now, man, we're looking good because the average on this type of question would typically for an A, B student, it would usually be, 3 or 4. We're already only in October. But, okay, would you find that sheet I gave you? All right. All right. Would you get out that summation notation page? This will probably take us the rest of the period. And we probably won't be going over more questions, so you'll be turning in set 41 on Monday. So don't sweat that. Just follow along. All right. So the lesson set 43, and I know we haven't done 42 yet. Don't worry, I didn't forget 42, but 43 is a bit of a humdinger, and I'm going to break it over a couple of days. So, Shiloh, you're a soccer player, yes? Yes. So why do you do drills? Why do you do a drill all day long and just stop? Why drills? Why not? Yeah, whatever. Why not just say, hey, let's scrimmage all period, every practice, all the time? Anybody? Yeah, okay. So in a game, you won't necessarily get enough trapping practice to get good at trapping, right? I mean, it's all over the place. And maybe you'll get 3 traps in practice, maybe not. So you do skills to get good at one little part so that then game time that skill's there, right? Same goes here. This is a lot of the little skills that are going to be needed in game time on Tuesday. By the time this is done, those skills will be there and Tuesday will go great. So, 3 skills I want to get across. It goes like this. Tuesday, yes. Tuesday is when I'm teaching set 43. Okay? Yeah, there's not actually a game. We're not playing a game or anything. It's whatever. I didn't want you to get disappointed. All right. Summation notation or segment notation. Let's get very clear here. When you see this, think S, not E. Okay, that is an S, that's a Greek S, not a Greek E. It stands for sum, okay? Sum. And you will see this used a lot in Calc 1 for Riemann sums and a ton in Calc 2 for infinite sums. So this notation is a higher level math idea that we use a lot. You need to be very comfortable with it. And that'll be the main objective today, making you comfortable so you don't see this and think, oh my God, what does it even mean? You're going to know what everything means, okay? So let's go with an idea we've been talking about, and that's area under a curve. Would you draw me a real wide, but with room a little below it, parabola from 1, shoot, 1 to 4. Okay? Okay. So, all day long today we're going to be using right rectangles and something else. Oh, equal subdivisions, sorry. So we're going to be using equal subdivisions and right rectangles. Okay, so don't get bogged down in that part. So, here's the deal. I think you'll agree that the area is many rectangles. Now, let's start with, instead of base 1, height 1, it's base 2, height 2. Let's just call it this, oops, sorry, erase that. Let's call it the sum of base I, height I. And that I is just a counter from 1 through however many rectangles we use. You follow? Now, the base of each rectangle runs along the x-axis. And so from one point to another, the base is a delta x. Or a change in x as you go left to right. The heights come from the function, and it kind of depends on if you're using right or left, but it's the function, but not just at any old x, but at different x's. And so we're going to write that as x of I. The function at different x's, sequentially. The first x, the second x, the third x, to get the first height, the second height, the third height. Are you with me so far? Are you with me so far?
Yes.
Cool. Let's go back over here. If I'm talking about the region from 1 to 4, say n equals 3. Now n represents the number of rectangles. So when I say n equals 3, that means use 3 rectangles. If I do that, then how wide is each rectangle going to be? 1. Now that came from the total width divided by how many rectangles? In this case, the region was 3 wide. I divided it by 3 rectangles, so that's 1 width per rectangle, right? The summation of this actually, so let's actually go here before we're ready for the summation. Let's draw the first height. The first height is going to be choosing between the function at 1 or the function at 2? Well, if I'm using a right-hand rectangle, then I'm going to use the function at 2. Then the function at 3. Then the function at 4. Would you, below these then, if you have room, and again, I apologize for the spacing if it's bad, but x1, the first x at which we drew the height, yes, it was 2, but I don't care about 2. I care about where 2 came from. And so 2 came from starting at 1 and going over 1 unit once. I know that seems trivial, but I just wrote 2 as 1 plus 1. Is that really necessary? Yes, that's necessary. Okay? X sub 2. Now, surely the second height, or the second place at which we drew the height, was to start at 1, and we went over 1, 2 delta x. So that came from 1 plus 2 delta x's, or 1 plus 2 ones. And x3, well, it came from starting at 1 and going over 1 plus 3 ones. Wouldn't you agree that's 4? All right. Now, having that written out long ways is the key to being able to write the summation. If I were to write the summation of this area, the area is the sum of many delta x's, or in this case 1, right, times f at, now the height is f at different x's. The first x was 1 plus 1 once. The second x was 1 plus 1 twice. The third x was 1 plus n, or 1 3 times. So if you were to write a general trend, isn't there a connection between the x you're at and how many deltas you've gone over? When I'm at the first x, I've gone 1 delta over. When I'm at the second x, I'm 2 deltas over. When I'm at the third x, I'm 3 deltas over. So generally speaking, when I'm at the ith x, I started at 1 and went I deltas over. And in this case, delta was 1. So when I go to write this in summation notation, I would say the heights are starting at 1 and going some number I over 1 unit each time. The summation notation then needs to communicate what was I going from and to. I started, now here's I. I represents how many deltas you went over. The first time we did 1 delta over. The second time we did 2 deltas over. The third time we did 3 deltas over. So I went from what to what? 1 to?
4.
Not
3,
4,
3.
3, okay? It's a count of how many deltas you went over, and really it's the same as how many rectangles you had, from 1 to 3, all right? Now, the x at which you draw heights then, when I say, hey, draw a height here at 1 plus 1, or 1 plus 2 times 1, or 1 plus 3 times 1, the x at which you draw heights depends on 2 things: the starting point and the number of delta x's you've gone over. And so the x sub I, the x at which you choose to draw a height, comes from the starting point plus some number. Now that's some number, rather than call it n, I'm going to call it I, of delta x's. As far as from where to where, we'll always starting with 1 delta x over, and we'll go with or go until we get the total number of rectangles they ask for, which is n. Now this can get pretty hairy symbol-wise, so if you have questions about what something stands for, let me know. But you might be just kind of, I'm just going to try and hang on and see if it all clears up, and that's part of it. So if you have a question, shout it out, and hopefully over the course of the problem I'll answer it. Now, imagine then if I did n equals 6, right? Now I'm not going to draw the whole figure again, but if you were to show the region here, we're going starting at 1 still and going to 4, right? Now let's start with delta x. How wide each base will be. Now I'm going from 1 to 4, but I'm breaking it into 6 rectangles. So if I take that region of 3 wide and break it into 6 rectangles, how wide will each base be? Okay. So the delta x is 3 divided by 6, or 1/2. So when I go to break up my huge area into little chunks, the first x will be, remember we're using right rectangles, so I'm not making the starting point 1 my first x, I'm going to the right side of my first interval. Now the first interval will be to start at 1 and go over 1 delta x, so that's 1/2 over. Okay, and that's too small to read. You follow? The second x at which I draw a height, well, I'm going to go over another delta x, so that would put me at a starting point of 1 plus 2 delta x's, or 2 1/2 segment chunks. If I go over another delta x, then x3 would be 1 plus 3 delta x's, or 1/2. What's x sub 4, or the fourth x? 1 plus 4 times 1/2. x5 is 1 plus 5 times 1/2. And x6 is 1 plus 6 times 1/2. Now that's the last one. I was doing 6 rectangles, so I'm done. What is 1 plus 6 times 1/2? 4. That's where I'm supposed to end, right? 4. Very cool? Okay, so if I were to write this in summation notation for n equals 6, then the area would be the sum of many, again, now think basis times height. In this case, what's the base? What? 1/2. The base is now 1/2. Delta x is 1/2, right? And the height is f at different points each time. Now that's different x's, but I'm looking for a trend in the x's. Rather than write x sub 1 or x sub 2 or x sub I, look at the more detailed pattern. Generally, the x is always 1 plus some different number of deltas over. Now that's the counter. Look at that. It's counting up. 1, 2, 3, 4, 5, 6. That's the counter of the summation, and that's the I. So when I go to write this, it's always 1 plus some number of 1/2. And that some number is the counter I. Now we started with an I of 1, starting with an I of 1 and then ending at an I of 6. That's the summation based on 6. Would you try and write the summation based on 100? Now please don't try and draw 100 x values. Try and jump to the summation. Start with saying, what's delta x? So do you agree the width is still 3? But
Good morning, Devil and Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So now we're going to have to figure out what to do.
Today, we will have a new procedure for purchasing your food in the cafeteria. You may not bring backpacks or books into the lunch line, and only 4 students can be in front of the counter at any time. You will notice that there are tables placed in front of each line. You can put your backpacks and books on these tables and pick them up as you exit after paying. Since only 4 students can be in front of the counter at a time, please form a line just behind the table. And as a student exits from the counter, another student may enter. Thank you for your help and cooperation. We hope this will make it easier for everyone.
Probably not.
National Junior Honor Society will meet in cafeteria today during 7 hours. Please sign up as counseling and report to the cafeteria. Let Mr. Northway know if you have a conflict.
Girls mentoring today for a fun, exciting discussion. Meet your doctor first.
Calligraphy Club every Friday in Ms. Bender's room E206. All are welcome, no experience necessary.
Selfie yoga related at 6 p.m. to 10 p.m. House for your desk volleyball. Get a yoga related class when you're ready for volleyball.
Today, many high-known colleges will be here and you will want to pass the campus. Sign up for Knox College, State University, Villanova University, Texas Christian University, Willamette University, and Johns Hopkins University. Understate the University of Northern College, Colorado,
Ah.
11th graders in class away will report to the cafeteria on Wednesday, October 10th, no later than 7:15 a.m. for the PhD. And then lastly, on Sunday, reward to the module. Bring 2 number 2 pencils, no mechanicals, a calculator with extra batteries, a drink, and a snack. Do not bring a smartwatch or cell phone. Cell phones and smartwatches are not allowed in test areas. 11th graders will be dismissed early.
How to do that?
10th graders will be required to 7th hour face-up lunch names on Monday, October 8th, Tuesday, October 9th, and Thursday, October 11th. Please plan accordingly.
We have Brandon, Phoenix, Isaac, JJ, and Starry going through the downfall of the
Really? So I got some bad news followed by some really good news. I'm going to have to change the schedule around. I'm going to have you do 42 because we're not getting through this. We're not going to be able to do this homework. I was going to have you do 42. That's the bad news. The good news is the printer's not printing. So I got and so I guess you have no homework. Except I'll send you the opportunity. Yes. Morning and sunrise. No.
Great throw, I swear. The receiver just dropped it.
The amount of times he had to put on a new jersey because like his jersey wasn't eligible.